Hey everyone, welcome back to the channel. Today we are talking about network switching, the backbone of modern connectivity. Whether you're setting up a new network or troubleshooting issues, understanding the fundamentals is the key. Stick around because we are breaking it down step by step. Let's dive in. So I mentioned some basic functionalities over the first page. So the first thing that is written over here is forward frame using MAC. So whenever a switch receives a frame, it forwards it to the correct destination MAC address. Okay. Second thing is learning MAC by examining the received frames. Okay. So when a switch receives some frame, let's say you are sending a frame to some other computer, then the port at which your frame is received, the switch will note it down in a MAC address table, and that port will be associated with you. The third thing is avoiding loops. Avoiding loops is a complex topic. Uh, in some cases, when two or more switches are connected and it forms a loop, then it creates a broadcast ROM, or it creates redundant MAC address copies associated with some ports. So we will discuss that later. Okay. Now the devices that are connected to a switch communicate using a Ethernet frame. So if a device is connected to this switch and the switch is again connected to some other device, if this guy wants to communicate with this one, it will send a frame which will have the address of this computer. And when the switch receives this frame, it does its first job, that is to forward the frame. Okay, to forward the frame from this switch to this computer. But this frame also has some other details as well. So the first thing is a preamble. A preamble, you know, uh, gives details that a new frame is going to start, and this SFD tells that preamble is over and the actual data and metadata of the frame is going to start. There is your destination MAC address. This is the address of the computer that has sent and created the frame. This is the type of data that is inside, if it is a IPv4 packet inside it or IPv6 packet, or is it a ARP. All this data is inside this, and inside this packet is your actual data. Okay, it is again encapsulated, right? And this is FCS. This is some sort of error checking. If your frame from this end to this end is received correctly, or is there any problem with your frame, is there any errors. So these things are checked using FCS. Okay. Now how it forwards the frame is shown in this picture. So Fred is trying to communicate with Barney, and he has prepared some frame and he has sent over the wire. So destination MAC is mentioned here. You can see that is starting from 0 to the switch receives the frame. Okay, frame came in F0/1. So F0/1 is the port number. Okay, at this port this frame is received. It is destined for this MAC address. So MAC address is mentioned here, and it will forward out of F0/2 port. So F0/port 2, F0/2 port number is associated, is connected to Barney. So it will forward the frame from F0/2 port number, and it will not send to any other port. See, this is the MAC address table, and from this MAC address table, the switch is deciding that we need to send this frame to this port F0/2. Now what happens if there are two switches connected, and this switch needs to know about the MAC address of both these computers, because anyways this computer is going to communicate with these two, right? So what happens, as you can see, that this computer which has MAC address ending with 33 is here, okay, at third number, and Betty's address, that is 44, is also here, and both are associated with the same port number, right? So whenever there is there is a computer that is on another switch, or there are more than one computers, they will be associated with the outgoing port of that switch, right? Now here Fred is sending the message to Wilma. See, her MAC address is mentioned in the destination MAC address. So this frame will come to this switch. This switch, by looking at this table, it will decide that this frame needs to be sent from G0/1. So it will travel to this switch, and this switch will make the final decision that F0/3 is the port number that is connected, at Wilma's computer, right? But the question here is, how is that learning the MAC address at the first place? So when Fred sends a frame for some other computer, then it will send it through this interface, right? So when the switch receives some frame at this interface, it looks at the source address of that of that frame. So at first place, see, the table is empty, but when the frame is received, it will update the table with the MAC address and the port at which the frame is received, right? And when the frame is sent to the destination computer will also reply back to that to the original source address. And when it replies back, it will be again updated to the table. Okay. But you must be thinking that when Fred sent a frame, it got updated at the table, right? This is Fred's MAC address and it is the port at which the Fred's computer is connected, right? But how did the switch decided at which port the destination computer is connected, right? So when Fred sends a frame, the switch receives it and looks at its table if the MAC address is connected at any port. And if it finds that there is no port associated with the MAC address, it will flood the frame. Okay, and what does flooding mean? It will send the frame at every port except the port from which it came inside the switch. Okay, so if Fred is sending the frame at f0/1, it will send out the frame at f0/2/3 and /4. And what happens that if the message is suppose for Barney, then Barney will reply back and it will get to know that the Barney's computer is at port f0/2. Okay, and other computers will simply discard the frame, and this happens every time when a new frame is sent which is not there on the MAC table. Okay, so when switches are connected in this fashion, we can see they are creating a loop. This will cause some problem in the network. Let's say Bob wants to send a frame to Larry, so it will send it at this port. This switch does not know Larry's address, so it will flood the frame. Okay, so it will come out of these two ports. Now Archie will receive this frame and it will again flood this frame because this switch also do not know what is Larry's MAC. Now the frame will be received at this switch from this port and this port as well. Now the first problem that we are witnessing is that this switch will see that Bob's MAC address is associated with two ports. Okay, from at this port Bob is also connected and Bob is also connected at this port. So this is a problem. Now another problem is when this frame is again transmitted here, it will indefinitely travel in this loop. So this is again a problem. So to avoid these loops, we have spanning tree protocol, which we will discuss more in detail in some other video. Okay, now let's configure what we have learnt till now so that you get a better grasp of all the concepts. So friends, we are inside our Cisco Packet Tracer simulation tool. Our topology is this. This is our switch and these are two laptops that are connected to the switch. In this I have opened the command prompt for laptop 0 and in this I will open the command prompt for laptop 1. This is the switch command line interface and let's see what is there inside the MAC address table. So we will type show MAC address table. So we can see that the MAC address table is empty at the first instance, and let us see what will happen if we ping from this laptop to this laptop. So I'm going to ping from this to this laptop. So ping 10.2.0.0. So I've got a reply back from laptop 1 and we can do the same here as well. Ping 10.1.0.0. So we have got reply from both the laptops. Now let us see our Mac address table. Now you can see that both of the device are updated on the Mac table and type as dynamic. That means I have not explicitly told the MAC address table or added these MAC address to the table, but when this laptop pinged to this laptop, it updated in the MAC table. Okay,